Welcome to the Air Force Training Corps. Here you will be learning the basics of plane navigation and aviation in general. When flying a plane, you must take into account many key factors. These include the heading of the plane or the actual direction that your plane is going, the course, the heading that you're attempting to follow, and finally wind speed. 30,000 feet in the air, the turbulence can greatly affect the heading of the plane. A simple guess can either help or hinder a plane in its course. Fortunately, a way exists to accurately predict a course compensating for wind speed. This involves many geometric formulas pertaining to the trigonometry and law of cosines. To start, you must set up a coordinate axis with north at 0 degrees along the upward-facing y-axis going clockwise. Each axis is east, south, and west respectively. So a bearing of 180 degrees would be south along the negative y-axis.
So now that we have bearings down, plotting a plane's velocity is relatively simple. To plot the course of a plane heading northwest at 100 miles an hour, draw a vector at 45 degrees with a measure of 100. Since wind speed is not yet introduced into this equation, this is also the course of the plane. Now let's have an example with wind. A plane is heading at 150 degrees with a speed of 150 miles per hour. There is a wind coming from the north with a speed of 20 miles an hour. Find the course of the plane.
We can find the course by using the law of cosines, which is b squared equals a squared plus c squared minus 2ac cosine b. In this problem, we will say that the heading is side C, the wind is side A, which is 20, and the course is side B. From the prompt, we know that C equals 150, A equals 20, and angle B equals 150 degrees. So using this equation, we get that B equals the square root of 20 squared plus 150 squared minus 2 times 20 times 150 times the cosine of B. Cosine of 150, sorry. Solving this, we get that B, our course, has a speed of 153 miles per hour. Next we use, but our course also includes a direction. By using the law of sines, shown here, we can relate proportions to accurately predict trigonometric values. The law of sines is sine of angle x over side x equals sine of angle y over side y. So by plugging in our earlier values, we can say that sine of 150 over 153 equals the sine of A over 20. By solving this problem, we see that angle A equals 3.75 degrees. So finally, we see that our course is 153 miles per hour, and we add the 3.5 that was found previously to the angle 150 to get our bearing of 153.75 degrees.
Well, students, we've taught you everything you need to know now. These essential techniques will make you successful in your career as a pilot, so make sure to keep them in mind. In high school, you may have been sitting in class thinking how useless this stuff was, but look at you now. Who would have thought these things would be applicable in real life? My best wishes, pilots, and I hope to see you in the sky someday.